Okay. Yeah. Together they make a straight angle. So if they make a straight line together, they're called a linear pair. So angle 1 and angle 2 today on this picture is called a linear pair. And what we know about a linear pair is together they make 180 degrees also. Okay? That angle 1 and angle 2 is a linear pair, that's a definition. The fact that they add up to 180 degrees is a theorem that we could prove. Although I'm not going to take the time to prove all these theorems because I'd be up here for a couple hours. But linear pair adds up to 180 degrees, that's a definition. That this two adjacent angles that make a straight line are a linear pair, that they add up to 180 is a theorem. I think they called it the linear pair theorem, actually. If you don't remember the name of the theorem, it doesn't matter. But if you have to reference it, you just say what the theorem is. A linear pair always adds up to 180. Just say that. Okay. Okay, linear pair, adjacent. Do you guys remember what it's called when two angles add up to 180? What those angles are called? It could look like a linear pair. It could just look like this, though. Okay, these two angles might add up to 182. They don't have to necessarily be adjacent. It's called supplementary. It's probably been a while since you've heard that word. Does that ring a bell for anybody? No. It's probably been like 7th grade, well, maybe 8th grade. Yeah. Maybe 8th grade too. Anyway, supplementary angles add up to 180. So two angles that add up to 180. So if one angle is 100 degrees, what's its supplement? 80 degrees. Okay, if one angle is 90 degrees, what's its supplement? 90. So linear pairs are, you could say, are supplementary angles every time. If they add up to 90, they're called complementary angles. They add up to 90 degrees. So if I have one angle that's 30, what would its complement be? 60, because 30 plus 60 is 90. Anyway, those are a couple definitions. All these definitions we need today. I think that's the last of the definitions. Yeah. Adjacent even isn't in that list, but we talked about it. In chapter 1, okay. So next thing. Angle 1, 2, 3, 4. What do you think we know about angle 1 and angle 3 in that picture? They look the same, don't they? How about 2 and 4? They're the same. In geometry, we don't say they're the same. What do we say? Congruent. So I could say like angle 1 is congruent to angle 3. Now they look the same. Does that mean they're the same? No. Not necessarily. But there's actually a way I can prove it, and I'm going to do that. So when two lines intersect those angles opposite each other, those are called vertical angles. Okay, that is a definition. 2 and 4 are vertical angles, 1 and 3 are vertical angles. We think they're the same. Let's see if we can prove that they're the same. What do I know about angle 1 and angle 2? They have to add up to 180, right? So, why am I putting this little n in here?
Because it's the measurement.
Right. The angle itself is not a number. An angle is just like a thing. This is not a number. It's just a thing. But there's a measurement of that angle that is a number. So it's kind of like saying, I wouldn't say Carson and Canyon, I wouldn't say they're equal. But I might say their heights are equal. Because the height is a number. They are people. They're not numbers. Anyway, that's kind of what's going on. That's why sometimes we use congruent. Because they're things that are the same. If angles have the same measurement, then they are congruent. And sometimes I use equal when I'm talking about the numbers. Anyway, what do I know about angle 2 and angle 3? They also have to add up to 180 because they're a linear pair also, right? Whoops.
All the way around it's 360.
Okay, now here comes a magic trick. Okay, I have been using the M symbol because technically that's correct, but I'm going to kind of cheat.
What's the M symbol?
Measurement, like how many degrees is it? I'm going to cheat and stop using the M symbol just to help me out with time here. Now, how the heck did I figure that out? Archer?
Because angles 1 and 3 are congruent.
No. Sorry, that's what I'm trying to prove. Now, that's not given to us yet. I'm trying to prove that vertical angles are congruent. That's what I'm trying to get to. But I don't know. I don't really know that yet. It has something to do with what we just set up here. 1 and 2 add up to 180. 2 and 3 add up to 180. Therefore, 1 plus 2 equals 2 plus 3. How did I figure that out? Okay, it's kind of transitive property, but I would think of it as substitution. If this is equal to 180, then I can put that right there in place of 180, right? Substitution. Substitution. If they're both equal to 180, then they have to be equal to each other. Does that make sense? This is kind of like the key line of a lot of proofs, most proofs maybe even. And then you remember yesterday when we said this little dealy-wop? What was that called yesterday? Reflexive. And why did we show that yesterday? Because I'm getting ready to subtract or divide or something. If I subtract that from both sides, I get the angles are equal. Or technically, I should write congruent. But if the measurements of the angles are equal, then they are congruent. So that's what I was trying to prove, that vertical angles are the same. I could do the same thing with 2 and 4. But yeah. Basically, because 1 and 3 are supplementary to angle 2, they both have to be the same angle. Like if I knew angle 2 looks like it's about, I don't know, 150 degrees. And I know it has that up to 180 with this, so this have to be 30. I know it has that up to 180 with this, so this have to be 30. So anyway, those two have to be the same. So, vertical angles is a definition, but vertical angles are congruent is a theorem that we may now use. So if we ever see vertical angles, these angles opposite each other, we can just say, I know those are the same. They look the same, and you guys guessed they were the same, because they are. If you think about it, it's kind of like scissors. When you open up one side, the other side gets wide at the same time. So they always stay the same. All right. Anyways, vertical angles will be used a lot. Lots. Okay, let me say a couple of duh statements here. This will sound confusing, but once you understand what they're saying, it's not. Supplements of congruent angles are congruent. Supplements of congruent angles are congruent. This is a theorem that we can use. So, what are congruent angles? Right. Two angles that are equal. So let's say we have two 50-degree angles. Those are congruent, right? What would the supplement of those angles be? What does supplementary mean? Adds up to 180. So if one of them's 50, what's its supplement? 130. So what would this supplement be? So what they're saying is supplements of congruent angles are congruent. Does that make sense?
Yeah.
The supplement to congruent angles have to be congruent. It's kind of a duh statement. Or you could say the supplements of the same angle are congruent. another does statement. Those are theorems that we might have to use later on. There's no name for that theorem, you just say it is true, like something we know is true. It's something that can be proven, so it's not a postulate. Speaking of postulates, I need to remind you of something from chapter 1. If I have this picture here, let's call this big angle, angle ABC. What can I say about this picture?
Angle 1 plus angle 2 equals angle ABC.
Yeah. So again, I technically I should be putting little ends in here, but angle 1 plus angle 2 equals angle ABC. I doubt you guys remember what I called that. I only referenced it once or twice. It's called the angle addition postulate. So if you have two adjacent angles, you add them together, they equal the big angle. Okay, angle addition postulate.
That's what?
Something we need to know. Angle addition postulate. No, we're not going to use abbreviations. And on the top of page 92, there's a bunch of little theorems there too. It says complements of congruent angles are congruent, just like supplements of congruent angles are congruent. All right angles are congruent. That's a does statement, because all right angles are what? 90. Congruent supplementary angles are right angles. What does that mean? Congruent supplementary angles are right angles. Means if you have two of the same angle that adds up to 180, what do they have to be? If you have two of the same angle that adds up to 180, what do the angles have to be? Whatever half of 180 is, which is what? 90. Okay, so what they said was congruent supplementary angles, two angles that are the same that add up to 180, are right angles. They have to be 90, right? If one angle in a linear pair is a right angle, well, guess what we know? If one angle in a linear pair is a right angle, then the other is 90. They have to be supplementary, right? Yeah. So those are things we can just say we know are true. That has to be true. Okay, we are doing the odds today. So what I told we're doing all of this, but I'm doing the odds with you. What I told the other class is for 38, it's like a do-it-yourself proof. If you can figure it out by yourself by tomorrow, I'll give you bonus.
How much?
I don't know, that would be worth quite a bit, maybe 3 points. It's probably like a 4 or 5 line proof or something.
What if we don't
If you don't get it by tomorrow, we'll do it together. If you don't get it right, you don't. It doesn't matter. But maybe if you get some of it right, I might give you 1 point. If you get like most of it right, I'll give you 2 points. Get it all of it right, 2 points, that kind of thing. It's challenging because it's a do-it-yourself proof. So if you don't get it by tomorrow, we're going to do it together. Page 92, 1 through 30. Okay.
Are the old books, do they have different
Yeah, those are
assignments?
garbage. Okay. Numero uno. You guys see the pretty picture there? It says, what kind of angles are angles GKJ? Which angle is angle GKJ? Which angle in the picture is that?
The top.
The top one. And angle HKI, which one is HKI? Bottom one. What are those called, the top and the bottom angles? Vertical angles. Okay, they are congruent, but that's not what they're asking. What kind are they? They're vertical angles. Okay, number 3, these are not protractor questions. Usually when they make questions like this, the picture does not match the angles, so you just have to know. How do we find the measurement of angle IKH, the bottom angle? Okay, what do I know about the 55-degree angle and that bottom angle?
They are equal.
Add them together, they make 180.
They make a straight line, they're a linear pair, so they should add up to 180. So to find the missing angle, you do 180 minus 55.
Do we show that? Do we show the answer, or do we just put it in
No, yeah, you solve it. You're supposed to find the angle.
the 25?
Yeah. 125. If we want to be technically correct, we should use the degree symbol that specifies what we're talking about, an angle measurement. Number 5, what is the measure of the complement of angle JKI? So what did complement mean? What's complementary angles? Add up to 90. So JKI, they tell us in the picture, is 55. So how do we find its complement? 90 minus 55. 35. 35 degrees. And how do we find, on the same question, how do we find the supplement of that angle? 180 minus 55, which we just did.
For number 7. Is that the one he was talking about?
Vertical angles are always congruent. Well, number 7, name 2 angles that are supplements of angle FGE. So, supplement means what? Adds up to 180. Remember, 2 angles that make a line together, a linear pair, should add up to 180. So what other angle with FGE would make a line? EGC would be one of, angle EGC would be one of them. Do you guys see that in the picture? Angle FGE and angle EGC together are a linear pair. Okay. Now, there's another one, and they're asking for 2. So somebody besides Archer. What angle is supplementary with angle FGE? And besides Canyon too, because Canyon answered the last one. What angle is supplementary to angle FGE? Yeah, Mason?
FGB.
FG, say again, I didn't hear it. FGB. Do you guys see that in the picture?
Did I get it right?
Yes. Okay, do you guys know what they're talking about? Okay, if you look at FGE, it looks like that. If you look at FGB, it looks like that. Together, they make a straight angle. They're a linear pair, so they have to add up to 180. They have to be supplementary. Number 9, angle. Find the measurement of angle FGE. Anybody have an idea for angle FGE? Archer and
You're on 11?
yes, 9. How can we find the measurement of angle FGE?
50 degrees.
Okay, why is it 50 degrees, Aiden?
Because 90 minus 40.
Okay, so Aiden said that angle AGE must be 90, because it shows a 90-degree angle right next to it. And he did 90 minus 40. Do you guys see the vertical angle? What's the vertical angle for FGE? Yes. You guys see BGC? There's a 50-degree angle over here. They called it BGC. BGC. And that is the same, it's FGE is what we were looking for right here. These two have to be the same, vertical angles. So yeah, it's 50. But yeah, Aiden said it right too. 90 minus 40 would also give you the right answer. Okay, number 11 says measurement, find the measurement of angle BGD. What does that have to be? Yeah, it looks like 90. It has to be 90 because it has a adjacent angle that's 90. So adjacent linear pairs, if one's 90, the other's 90.
So it's just 90?
Okay, 12, I'm not going to go through this, but 12 says classify each angle. What do you think they mean by classify? Acute, right.
Straight.
Yes, acute, obtuse, right, straight, those kind of angles. 13, okay, if you forgot these properties, you might have to turn back to page 79 to see what they say. But it says, write a statement to illustrate each property. Reflexive property for congruent angles. Does anybody remember what reflexive said?
Like it's the same,
Like A equals A, right. So, but we're doing it for angles, so just say like angle A is congruent to angle A. I think that's on page 79 if you forgot the properties. 15 says transitive property. You guys remember transitive property? It's if A equals B and B equals C, then A equals C. That's transitive. Like train, they're all connected. So what would that look like with angles?
So angle A equals angle B.
Angle A congruent to angle B.
And angle B equals angle C. Then
I'm doing
angle
congruent.
A equals
Congruent instead of equals though. Angle B is congruent to angle C.
Angle A is congruent to angle C.
Angle A congruent to angle C. If A is the same as B and B is the same as C, and A and C are the same. That is all it means. Okay, on 17 it says name the definition, postulate, or theorem that justifies each statement. So how do we know what they're saying? 17 says if angle C and angle D are supplementary, then the measurement of angle C plus the measurement of angle D equals 180. Okay, how do you know that? So if I tell you angle C and D are supplementary, how do you know that they add up to 180? Because that's what supplementary angles means, right? So what we're going to put is definition of supplementary angles. We know they have to add up to 180 because that's what supplementary means. So it's the definition of supplementary angles. Oh, funky yes. Okay, 19. If angle X and angle Y make a linear pair, then angle X and angle Y are supplementary. How do we know that's true? No. A linear pair's definition is just two angles that make a straight angle together, basically. It doesn't tell you they add up to 180. That they add up to 180 is actually a theorem. Okay, if you don't know the name of the theorem, you can just say what the rule is. Linear pairs are always supplementary, right? But that is called a linear pair theorem. It's called the linear pair theorem. Okay, on 21. Okay, how can we figure out what x is on 21? What's the relationship between those two angles? They're equal. How do we know they're equal? Because they are what? Well, why do we know they're congruent?
They're right.
They're adjacent.
No,
Just against side.
they're not adjacent. They don't share a side. What are they called when they're across from each other like that? Vertical. Wake up. You guys are all asleep. So if they're congruent, what equation can I use? If those two angles are the same, what equation can I write? Guys, come on. Somebody engage your brain. Somebody besides Archer. Or we could just sit here all day and do nothing. I'm cool with that too. I'm not calling on the Archer.
13x equals 7.
Okay, if the two angles are the same, then the two things are the same. Not rocket science. If the two angles are equal, then their stuff is equal. And then you just do algebra to solve it. What would be the first step in algebra? Distributive property. So 13x equals what?
7x.
What do we do when we have x's on both sides? Minus 7x. Okay, so that would be the question A, x is 7. Question B, find the measurement of angle AED. How can we find the measurement of angle AED? It's not 90. Right, we just figured out x was 7. So if we put 7 in there, that will tell us the angle. 7 plus 6 times 7. No.
91.
7 plus 6
90.
times 7. 91. If you just plug in 7 plus 6 times 7, why would your calculator get that wrong?
Order of operation.
Order of operations. Alright. C says find the measure of angle CED. How can we find measure of angle CED? Out to the right there.
So 91's from 180, which is.
Right, so we just figured out that bottom angle was 91, right? That's what we did on the last problem. We just figured out this was 91, so how do I find this one? These two together make 180, right? All these pairs make 180. That pair, that pair, that pair. So 180 minus 91 is 89. Okay, 23. What do I know about those two angles?
They equal 90.
What do you mean they equal 90?
I mean equal a right angle.
The big angle is 90, so what can we do with that? So what do we know about the little two angles?
It's roughly 4 degrees.
How can we, what can we say about those two little angles?
Add them together. And
They should add up to what?
then 90 degrees.
90. Okay, so what should I write then?
4z plus 7z plus 2.
Together they should make 90, right? Add them up, they add up to 90. 4z plus 7z is 11z.
Oh, minus 2.
88.
11z, if 11z is 88, and z is 8. So that would be the A answer. If z is 8, how do I find the measure of angle GHJ?
You have to find the angle JH
No.
4 times.
Right, it says GHJ is 4 times z. You guys see that? So you just do 4 times 8. And then for C, it says find angle JHK, the other angle. How would I find angle JHK?
When is it at 90?
Put 8. 7 plus 8 plus 2.
Yeah, you can do 7 times 8 plus 2, or you could do 90 minus the answer from B. Okay, on 25 it says angle 1 is supply each missing statement. Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. Therefore, what? Hint, we're using the transitive property.
Oh, then angle 1 equals, equates to angle 3.
Right, the angle 1 is congruent to angle 3. (27) If W is a point in the interior of angle XYZ. Let me draw a picture for that. So here's angle XYZ. W is on the interior. Let me draw a line through there. So it says angle addition postulate. What does the angle addition postulate say about this?
Angle X, Y, W.
Right.
W,
Angle XYW plus angle WYZ equals angle what?
X, Y, Z.
XYZ. The two little angles add up to the big angle. That's all we're saying. XYW. So you go from, when you're naming an angle, you go side, vertex, side, just like you're drawing the angle. Okay, on 29 it says, well, it leaves the first line blank, but then the second line says angle A and angle B are supplementary by the definition of supplementary. So, how did they know the angles were supplementary, do you think? Because they added up to 180. So guess what that first line must have said?
Angle A and angle B equal 180.
Right, measure of angle A plus measure of angle B equals 180, yes, that is correct. Angle A plus angle B equals 180. Alright, try the evens.